Hello students, it is the second lesson on the NX course from the manufacturing process. Today we will learn on how to put the dimensions on the existing sketch, on existing simple sketch, and how to put geometric constraints on this sketch. So it is generally considered a good practice to ensure that every sketch you create is fully constrained before creating solid features. The term fully constrained means that the sketch has a defined shape and size. You can fully constrain a sketch by using the dimensions and constraints. As you create a sketch in NX, some dimensions are added to the sketch elements. These dimensions are called driven dimensions, and they do not have any control over the sketch geometry. If you want these dimensions to control the shape and size of the sketch geometry, you have to convert them into driven dimensions. Driven dimensions are also named because they drive the geometry of the sketch. You can add driven dimensions to sketch by using the rapid dimensions command. So NX environment is opened already. Here press the sketch and press the plane as usual. Every time when you start with a sketch, you have to always define the plane where you want to draw your sketch. Press OK. That plane is defined. So in the driven dimensions, the sketch using the rapid dimension command. So here you see the rapid dimensions command. You can use this command to add all type of dimensions such as the length, angle, and diameter. These commands create a dimension based on the geometry you select. For instance, to dimension the circle, activate the rapid dimension command and then click to the circle. Next, move the pointer and click again to the position the dimension. You will notice that the box pops up. Type in value in the box and then press enter to update the dimension. So, firstly, create the circle with the method of the center. So create the circle and click the dimension, rapid dimension, and click the circle, drag and drop the dimension and press mouse. So here you see dimension is given and we can put the rapid dimensions in the driven dimension. For example, we will type, for example, it's 100 and press enter. So the diameter of this circle is changed. This is the how to put the dimension on the circle. So this is the one mode. Also we can put the dimensions in the rectangle. For example, to drop the rectangle by the 2 points, first point and the second point. Rectangle is created. Press the escape in order to deactivate the rectangle. So press the rapid dimension. Let's move it here. Then press the length and press, it is the 101 millimeters. So we will change it, for example, 110. Okay, 110. Press enter and the height, for example, 70. You see, it's become 70 and press enter. So it is how to use the rapid dimension. It is how to use the rapid dimension. So press escape. Also we can put the dimension here, the lines. For example, draw the line, drag and drop and press again. So press the rapid dimension and press the line. It is 116 and we would like to that length of this line is 200. Press enter and it will become the 200 and close the line. So this is the method of to use the rapid dimension. So there is also several methods to put the dimension. For example, linear dimension, angular dimensions, and vertical dimensions for the lines. For example, let's firstly delete this sketch. Okay, select first all and For example, linear dimensions. For example, we will NX allows you to create the various type of the linear dimension. Select, for example, firstly draw line, horizontal line. Then from the rapid dimension select, and here you see the methods. If you open the methods, you will see the several methods of putting the dimension: horizontal dimension, vertical dimension, perpendicular, point to point, angular dimension, radial dimension, and so on. For example, the horizontal dimension, put and for example 200, okay, 50. If you draw the vertical line, for example here, and select the dimension, and if you use the horizontal dimension, this only, if you select here horizontal dimension, this only gives you horizontal dimension of the inclined line, for example 100. And if you change it to the vertical, this gives you only vertical line. You see, this also, let's do 100. Let's close. If you draw the inclined line and select this, just this one, and make it inverted, and you can, in this case, you can choose any direction. For example, you can choose horizontal or vertical or actual length of the line. For example, actual length is, you can put for example 150. This is the how to use the several methods of putting the dimensions. Also, let's make the one line here, two lines with any angle. So you can create the angle between the two lines, angular dimension. So select this one, and put the angle, for example 120. So angles becomes 120. This is the methods of putting the dimensions. So let's see one more time. For example, horizontal line, here the rapid dimension, here for example horizontal line, only horizontal dimension because it's constrained here, the only horizontal, for example 100. Okay, it's clear. Then here vertical, only we will select vertical line, so it's constrained vertical, so only vertical. If you move any kind, only shows vertical line. So vertical also, let's 100. If you draw line and just click rapid dimension and only, and select here not horizontal, not vertical, just inverted, okay, you can select the, put the dimensions actual length of the line, also the horizontal and vertical, if you move. So actual length you can put, for example, also numbers is just numbers I am putting here. Okay, select and delete. That's about the dimension. Let's talk about the over-constrained sketch. In the NX environment, there are some cases there will be the over-constrained sketch. For example, draw the rectangle for the beginning. So when the creating sketch for the solid or surface feature, NX will not allow you to over-constrain the geometry. The term over-constrain means adding more dimension than required. So you will add more dimension than required. The following figure, that's rectangle, shows the constrained sketch. So if you put dimensions here, for example the 160, let's put it 150, press enter, and for example let's 100. we defined two sides of the rectangle. It means it is fully constrained. Let's delete these ones. Okay, the system is fully constrained because two sides are fully defined. So this is the fully constrained. So if I would like to define the diagonal of this rectangle, you will alarm it with the red with the update sketch alarm. So this means that your system is over constrained. So it means that this diagonal is not required because two sides is enough to define your rectangle. So in this case, press OK, and in order to decrease the over constrained level, just select this one. You press this diagonal and convert it to reference. Press this one. So this becomes the reference line. It is additional line, so your system will not become the over constrained system. So you have to avoid the over constrained system. So the alarm of the over constrained. So this is the how to put the dimensions. Let's see simple examples on the how to put the dimension for the other elements. For example, the arc. Let's draw the arc from the center point, radius, and last point. So if you would like to put the radius for this arc, let's select this arc, and it is the 79.4 and I would like to hit 100, for example. It will become, the arc will become 100 millimeters. So this is how to put the dimension using the rapid dimension in the arc. So delete this one. Next phase of the hour is our lecture of today is the geometric constraint. This is also one of the important point of our lesson because the geometric constraints is mostly used command in the sketching environment to draw your sketch in the properly. So geometric constraints are located, if you look here, the more, if you open the more, you will see here the geometric constraints. So click the geometric constraints and you will see here several types of the geometric constraints. It is the collinear, coincidence, equal radius, or parallel, vertical, and so on. We will see all of them step by step. So geometric constraints are used to control the shape of the drawing by establishing a relationship between the sketch and element. These geometric constraints can be applied using geometric constraints commands here. Then from the more, if you open the more, so first type of the geometric constraints is the coincident. This constraint connects a point with another point. Select the point to be made coincident and click the coincident icon on the context toolbar. The selected point will be connected. So in order to activate the constraint, let's firstly draw two lines. So let's draw one vertical line and one horizontal line. So I would like to connect this point with this point. So then open the geometric constraints. That's the coincidence that constrains two or more vertices on the one point, this one, and here you have to select 2 points that select the object to constrain. So select this one and select this one. These 2 points is constrained, okay, to become coincident. This is the way of to making the coincident to become the coincident. So next is if you open the geometric constraint, is the point on the curve, this one. point on the curve. This constraint makes a vertex or point to be on one line, curve or arc or circle. Select the, let's draw the same as two lines here, horizontal and vertical. Open the geometry constraint command. So select the curve and point on and click the point on the curve. So select this and select this. This will become in one line. So this is the method how to use the geometry constraint point on the curve. So press close and let's delete all. To continue with the next geometry constraint, firstly draw any line. Let's put the dimension, let's 80. Okay, let's incline it dimension. Let's put the dimension for it, actual dimension, for example 100. Okay, 100 and open the geometry constraint. Next is the geometry constraint is tangent. This constraint makes arc, circle or line tangent to another arc or circle. So it will becomes the tangent. So select this one, select the line for the first line, and for the second select the circle. So it will become here the tangent. Okay, circle and the line will become tangent. This is the very useful commands in the real cases. Okay, next is next is draw two, for example, lines. So any line, you can, for example, put the dimension. That's using the rapid dimension. Actual dimension, for example, 150. You can move the dimension into the size. And for the second is, for example, 100. So open geometry constraint, and the next constraint is parallel. So select the parallel. Okay, select this one first, the line. For the second, select this one, and they will become parallel. You see here the symbol of the parallelism. It means that these two lines are parallel to each other. This is the method of making parallel system. Next is concentric. So how does concentric constraint is work? In order to do this, let's draw two circles. For example, this circle. Okay, let's remain this circle. Okay, not draw. Okay, let's put the dimension for this circle. For example, 50 millimeters. Okay, open the geometry constraint, and here you will see concentric function. This constraint makes the center of the arc, circles or ellipse coincident. Okay, they will make the center of the arc, circle and ellipse coincident. So select this one. For the first object, select this circle. For the second object, select this one. So the circle of the centers will become in one point. It means it's concentric. So okay, it's clear. Next geometric constraint is horizontal. Let's draw one inclined line. Let's put dimension for that actual dimension. Let's 150. 20. If you see it is inclined line, let's open geometry constraint, and here you will see the horizontal constraint. That means if you select this one and select this inclined line, it will become horizontal. Okay, as well as you can make the vertical line. Let's draw line, put the dimension 150, close. Okay, geometry constraints, and you see here vertical. Select the vertical and select this inclined line. It will become vertical line. Okay, this is how to make vertical and horizontal line. Also, we will see now equal length geometry constraint here, equal length. So in order to make the equal length, let's draw one line, for example this line and this line. Okay, you have not to put the dimension for in this kind of concept, because if you put the dimension and use the equal length constraint, it will be over constrained function, because you putting the dimension, it's also one of the one is the making the constraint. So two constraints will become lead to the system over constrained. So geometry constraint here, equal length, this select this one, and from here select this one. This will become in equal length. So this symbol represents this, and this one is in the equal length. So if you must, for example, the if you would like to uh, check the length is 130, and this is also 100. So it means that it's overcome, because all of this one is equal this one. Okay, let's delete this one. So this is how to make equal lengths. Also there exists the equal radius. For example, select the circle and open the geometry constraints and make, for example, equal radius here, and select this one. For the second, select this one. It will become equal radius for this one. It's 80 millimeters in diameter. If you check this one, it will become also 80, since it shows that system is over constrained, because we already defined that this radius, diameter or radius, equal to what this is. So that's why it's not necessary to show the diameter for this circle, because it is same. This one is symbol, you see here, symbol, and this symbol is shows that they are equal radius. So next is, let's draw this and put for example the dimension 100, it's any dimension, and one, and open the geometry constraints. Here we see the perpendicular constraints. So I would like to make perpendicular of this line to this one. So select this one and this one. This will become perpendicular in 90 degrees. So let's move, and the next constraints. In order to make the next constraint, let's draw one simple object. So rectangle, let's put the dimension for the rectangle. So let's remain 180, and what is 100? Let's make it 110. Press enter. So then draw one small circle here. Let's put the dimension for it, for example 20. So let's open the geometry constraints, and you see here midpoint. That means this I would like to make the midpoint this circle on the this okay, select this one and select this one. So this circle will become in the midpoint of this line. So it is in the if it is in 180, so it is in a distance of the 90 millimeters. If you check the dimension, now it will be over constrained. So over constraint is 90 because it's over constraint, because I already defined it that it's in the midpoint, so it's not necessary to put the dimension here because it's already defined that it's in the 90 millimeters. That it's clear. So in order to continue the other constraint, let's firstly draw one simple object with using the profile command. So it's just a simple object. Let's firstly, okay, press escape. That I would like to make the collinear of this line with this line. So open the geometry constraints. Here you will see collinear constraints. So select this one and select firstly this one, and this will become decreased until this. So select this one and this. You see it will become the collinear two lines. It's also most commonly used constraints in a real application. Okay, that's all about how to put the dimensions and geometric constraints for the simple sketch. From the next time, we will learn how to make the patterns, symmetrics and mirrors more complicated sketch techniques. Then we will make exercise on sketch techniques, two-dimensional sketch. So that's all for the today. Thank you very much and see you on the next lessons.